Okay, this will be our last video for section 16.3, and I just wanted to discuss the vocabulary a little bit, particularly for those of you who are taking physics, because we're using some pretty loaded words. We're saying when we've got that F is a gradient field, F is conservative, and little f is a potential function for it. Well, in physics, there are lots of things that are conserved, and we have this thing called potential energy. And so these are sort of loaded words that suggest that we're maybe talking about something like that. And especially because I know that the integral, if f is a force field, and I take the line integral of f along c, that's going to give me work. Okay. And work can be defined as a change in kinetic energy. It can also be defined as the opposite of the change in potential energy. And the fact that the change in kinetic energy is the opposite of the change in potential energy is simply a way of saying that energy is one of these conserved quantities. Now, if you are not taking physics, I'm not expecting you to understand everything that I'm talking about here with kinetic energy and potential energy and all of that. This is just a little bit of information for those of you who are interested in the physics, okay? Not something I'm going to hold you responsible for in this class, but I think it's nice to know why we're using such loaded words, okay? So energy is this thing that's conserved, okay? And conservative force fields are used to calculate work, which is a change in kinetic energy, or the opposite of change in potential energy, that conserved quantity. Okay. Now, that means when we're calling f a potential function, that's actually a little bit of a misnomer. Because when I calculate the work integral, what we get is that it's the change in the potential function, which suggests that we should maybe call it the kinetic function, but we call it the potential function. This is actually giving me the opposite of the potential energy. So again, if you don't have a physics background, not concerned that you're familiar with all of these concepts, but I did want to explain why we use such loaded words for those of you who are familiar with them and are interested in the physics.